Live. So today what we want to talk about specifically is complex numbers. Okay, what a complex number is simply this. It is a real number plus an imaginary. Okay, complex number is a real number plus an imaginary. Okay. An example would be 3 plus 2i. That's a complex number. Okay? It has a real number, and then it has an I. And we're going to talk about what I is here in a little bit, okay? But this is a complex number. It has a real number, and it has an imaginary. Now, they come in pairs. Complex numbers come in pairs. They come in pairs because they come from x squareds, okay? They come from x squared equations. And we're going to take a look at one here real quick, okay? So this pair would be a 3 minus 2i, okay? They come in pairs. 3 plus 2i, so there has to be another one. 3 minus 2i, okay? They always come in plus minus pairs, which makes sense because they come from square roots. When we take the square roots, you get the plus minus, right? So an imaginary number, though, is some square root of -1. Now, I told you before, it won't work because it's not real. It's not real. It's only imaginary. So the square root of -1, we're going to call I. So anytime you see I, anytime you see this symbol I, we're talking about the square root of -1, okay? All right,
well,
so
it was like the square root of -3.
it's going to be the square root of -3i, and we're going to talk about it. Yes, very good.
So
Okay,
3i? What?
it would be 3i. Yeah. Yeah. So, Autumn, as always, you're ahead of us. I like that. Well, great question. I'm going to answer that, okay? It's a really good question. So, now, what is I squared? You've got to know this. Because how does that electron come back and become real again? Well, when you square I, okay, when you take and you have I squared, so if you have I is equal to the square root of -1, right? And if you square both sides, because I want I squared, all right? If you square both sides, because if I've got I equals square root of -1, and I want I squared, and I square both sides, well, I squared is equal to -1 because the square cancels the square root, doesn't it? Right? Doesn't the square cancel the square root? Yeah. So you wind up going from an imaginary number to a real number. And that's the same thing that happens to that little electron is all of a sudden it goes from an imaginary particle to a real particle, okay? All right, now, we're just going to manipulate these. This is not difficult, but so let's take a look at example 1. Now, before we said we couldn't take the square root of -36. Well, let's rewrite this. Square root of 36 times the square root of -1. Okay, yeah, that makes sense. Square root of 36. Square root of -1 because together they make the -36, right? Square root of 36 is 6, and the square root of -1 is I. So my answer is just 6i. And that's how we deal with the negative square root, okay? Square root of 36 is 6. Square root of a negative number is just I. So it's just 6i. That's it. So anytime we get a square root inside, anytime there's a negative inside the square root, we're going to have an I answer, okay? R2, yes?
So you just stuck -1 in front of that number because there was a negative there?
Sure. How do I make, what times what makes -36? Well, 36 times -1.
6.
And the square root of 36 is 6. And this, we said, is I. So the same thing on example 2. Now example 2, I might do a little bit more work. I'm going to go 9 and 2, yes.
3 and -2i.
And we got our -1, okay? Totally right. 9 and 2, so it's nothing new. 9 and 2.
Uh-oh. Somewhere.
And here we go. So now we just have to finish this. In Autumn, this is going to answer your question. Okay. So then I'm going to get a 3 square root of 2i.
So it would be y.
I is on the outside.
Why can't it be next to 3? Oh, because there's 3 square roots of 2.
No. Yeah, Derek, actually, very good. I like this answer. A lot of books, like textbooks, like it like this.
So it can be next to.
It can be. I disagree because they will say, most books will say it's supposed to be the form of a plus bi. Okay, you with me? Almost every book says it's got to be in the form of a plus bi. So then if you put it there, it doesn't follow the rule, right? But you'll see that many books like it like this. I prefer it like this. I like the I on the end. I would never count it wrong if you put this, okay?
So if we put that on the test, you would never count it.
Never. I would never count this wrong, right? In fact, when you see the answers to, like, probably your workbook, they probably like this. I prefer this. Yeah, Cameron?
So why don't you just make I the square root of negative 2?
Be the square root of negative 1, you mean?
No, like
No, negative.
take out the square root of negative 1 and just make square root of negative 2i. And you have your answer. just be I. So it's
Oh, I think I know what you're saying. Here, I think you're saying this. I think you're saying, if I'm wrong, just correct me, okay? I think you're saying square root of 9, square root of negative 2.
Mhm.
Is that what you're saying?
Yeah.
So then you're saying 3, and then what are you going to write here?
I.
Well, what about the square root of 2?
Is that just turn into I?
That's still part of it.
What if you put the negative?
No, yeah.
It should be 2i.
Yeah, it should be 2i.
So you still have a square root of 2. You still have a square root of 2, don't you? So you've got to have that in the answer, right?
So either way, you're gonna.
So you can go a square root of 2 and then your
And
I,
then you have your
right? You with me?
If you were to do it, you would get the same.
You got the same answer. though.
Same answer, right? Okay, now, Aiden, you asked a good question too. What, put the negative here, right? Right? So then we get the 3. We'd have a 3i square root of 2, so still get the same answer, right? Yeah, it doesn't matter. I like to write it this way so you'll see the I. You guys, you'll see the I. That's why I write it like this. You see 3 square root of 2 and you definitely see the I, right? That's why I do it this way. Get your total correct? Okay. All right, good job. And Cameron, you're totally correct as well. I'm just going to do it that way. It's easier to see. Okay, example 3. So we've got a real plus an I. Let's find x and y. Well, okay, this is super easy, right? So we've got a real with a real. Okay, so then I can say, well, 3x has to go to the 15. That's a real number. There's no I. You guys agree? So I'm going to put the 3x equal to the 15 because we put reals with reals. X is 5. Reals go with reals. So I'm going to put my 3x with my 15. Real numbers with real numbers. Okay. Divide by 3. X is 5. 2i and the 10y is in the I spot, right? So I'm going to go also 2i is equal to 10y, right?
Is it negative 10?
It's negative.
Oh, sorry.
Yeah.
And wait, why is that not a real number?
Because it's in, we don't know what y is, but most likely
Well, we
it
don't
is.
know what x is.
But they're written in this form. Good, a plus bi. They're always written in this form. So it's always real plus imaginary. So if these two are equal, if they are equal, then the 2i has to match up with the negative 10i, okay? If they really are equal, then these are the reals, these are the imaginaries, okay? So let's solve for y. Divide by 2, or just, sorry, divide by negative 10, divide by negative 10, and I get a 1/5 I is what y is equal to. Yes, Cameron, thank you. Okay, yes. Okay, now, 3, easiest of all. Think of them as x's. Just think of them as x's, okay? Just add the things are the same. Reals go with reals because they're real numbers. I's go with i's because they're imaginary, right? So 9 minus 4i. Done. Done. You ready? 9. See the 9?
Don't I think
I'm gonna
it's
positive 3.
Minus 4i.
9.
They're adding.
Oh.
I'm adding. So you only add real numbers with real numbers, right? So
So there's no
4
factoring
plus.
in there?
No, this is just plus. Just plus. We're adding them, right?
Okay.
So I'm adding it, and when I want to add it, real numbers, 4 plus 5. Those are the real numbers, aren't they? It's 4 plus 5, 9. Those are the real ones, right? And then 3i, negative 7i. Put the i's together. We're going to get a negative 4i, okay? That's it. That's it. Is this easy? Okay, yeah, Aiden?
As you said to start, it said you have to have pairs, so it's inside pairs. So do we not need the pairs for example 3?
If it came from an x squared, yes, but it didn't come from an x squared. Okay, so it's down. Hey, good question. Good question, really good question. Okay, now, difference. We're just going to subtract them. Okay, you ready? 5 subtract 6, negative 1, right? Let's be careful. We're going to have a double negative. Negative 2 subtract double negative, right? So this is really like saying negative 2i minus a minus 2i.
Just be a negative.
So it'd be 0.
Yes. You guys see the double negative? So it's negative 2 minus a minus, see the minus a minus, plus plus.
0.
So my answer is just negative 1. You could put 0i, but that'd be silly, wouldn't it? You could say negative 1 plus 0i, but that'd be silly, right? So here's the trick. Minus a minus, right? I'm going to subtract a negative 2. So I'm going to subtract negative 2, okay? So I'm just subtracting. Or you could take the trick I taught you a long time ago. What was the trick I taught you a long time ago? Bring the negative through. Remember how I brought the negative through?
Wouldn't you add it?
And then you'd have
6 plus
5 minus 2i minus 6 plus 2i if you bring the negative through, okay? Either way. All right, now, before we do example 6, okay, example 5, what is I squared? What is I squared? I squared is negative 1. So if we get an I squared, when we multiply, we change it to negative 1, okay? When I multiply, when I get an I squared, we change it to negative 1. So let's multiply. This times this times this. 10i plus 12i squared, right?
So now it's just negative.
It's just a negative 2.
Is it negative?
Okay, I squared is negative 1.
Negative 2i.
It's negative.
So we're going to get a 10i plus 12 times negative 1 times negative 1. I squared is negative 1.
Why can't it be?
Okay, which is 10i minus 12, right? And that answer is very acceptable. However, it should be real first. So it should be negative 12 plus 10i. If you do not do this, I would never count it wrong. But the rule is reals are in the front, then a measure. So I've got the 10i minus 12. I just wrote it as minus 12 plus 10i, okay? All right. Now, let's FOIL. Let's FOIL, or double distribute, okay? So remember, I squared is negative 1. So let's FOIL. 5 times 4 is 20. 5 times negative 3i is a negative 15i. 2i times 4 is a positive 8i. 2 times negative 3i is a negative 6i squared. Okay? I have an I squared. I'm going to make that a negative 1. Anytime you see an I squared, make it a negative 1. So I've got a 20. These two can be added. These two can be put together. They're both imaginary. Negative 7i minus 6 times negative 1. Okay, so I did two things. I combined negative 15i and 8i. I made a negative 7i, and then I made the I squared into a negative 1. Okay, I did two things. I did this and this. Okay, so then I've got a 20 minus 7i plus 6. Plus 6 because negative 6 times negative 1. Oops, sorry, my bad. Okay, positive 6. That's all I did, positive 6. All I did, positive 6. Now, 20 and 6 makes 26. 26 minus 7i, and that's my answer. Okay, almost done. This is not that hard, is it?
No.
As long as you remember, I squared is negative 1, it's not bad. Okay. Now, here we go. What's the complex conjugate?
220. Is that it? What is that number?
Okay. Say again, Brett. What's the complex conjugate?
4 plus 2i.
Now, what would happen if we multiply these together? Okay. So if we took our 4 minus 2i times our 4 plus 2i, when we did the conjugate with square roots, the square roots disappeared, right? So if we do the conjugate with i's, the i's will drop out, okay? So let's check it out, okay? So here's its conjugate, so it's like its opposite, right? When we did square roots, it helped us get rid of square roots. So when we do it with i's, it'll help us get rid of i's, okay? So 4 times 4, 16. 4 times 2i is a positive 8i. Negative 2 times 2i times 4 is a negative 8i. And negative 2i times positive 2i is a negative 4i squared. Okay, check it out.
It's just
Go through the
20.
FOIL. Yeah, R2.
So exactly what is the conjugate?
It's just going to be the opposite of that.
Okay.
So if that was plus, I'd make that a minus.
Okay.
Since it's a minus, I make it a plus. That's all we do. It's just the opposite of that. See how it is?
Yeah.
Okay, then, let's see what happens. Cancel, cancel, right? I got a 16 minus 4 times negative 1, right?
It'd be just 20.
Yep. I get a 16 plus 4, right? Which is a 20. No more eyes, right? No more eyes. Eyes are gone. Okay, real quickly, let's take a look at page 137, and then we will be done, okay?